Hello friends, welcome to another video on my YouTube LangChain series about chains. So in this video we will cover few chains. In the last video we covered three chains, right? Sequential, parallel and simple chains. In this video we will cover few more. So let's start with the router LCEL chain. A router LCEL chain decides which chains to execute based on the user input. So all the chains that you have seen in the past video, they are like there were not decision made, right? Like all the chains were getting either executed parallelly or they were getting executed sequentially. In the router LCL chain, it decides which chains to execute based on some input conditionally. So like a if else thing, like if this is the input of the user, then this chain will get invoked, else this, things like that. So let's jump into the example. So if you will see, I'm doing the things similar as we have seen in the previous examples. I'm creating different simple chains first. So my first chain is match chain. I hope you are all now aware of this string output parser and what it does. You have played with it. So we are creating a match chain now, which is like to solving a math problems using step by step. And then LLM parser. Again, the LLM I have created like above in the previous blocks, right? As you have seen in the previous video. So I will be using the same LLM. I'm not creating LLM object again and again. Now this is code chain, which is asking to explain the following programming concept clearly about this input and all. Then there is a general chain, answer the following questions clearly in a general manner. So now to make use of this routing chain, you have to create a classifier as well, right? Like you need to find out which chain to execute when. So either you can use LLM for that or you can write your own custom logic, up to you. So here I have created a classifier prompt. So in this prompt, classify the user input into exactly one category, math, code or general, and then return the category name only. If it is math problem, then math. If it is a coding problem, then code, else general. So this is the prompt I have created for the classifier chain. So here I'm using that prompt as a classifier prompt, LLM and parser, simple chain for the classifier thing as well. Now after that, I have written two functions, like if for the if else condition, like if condition true then execute this, else condition true then execute this, else. So for those conditions I have written those conditions as part of a function. So when will the match chain will get executed, right? So match chain will get executed when the output of this classifier is math. The category that is written by the LLM is math, right? So that's what I have defined in this small function xroute.strip.mat. So this is the condition which should become true to execute the mathematical chain. Similarly, in this code block, this condition should be true to execute the coding chain, right? So that condition I have written here. I am returning a true false as the output, just to make sure, like if this condition is true, then returns then invoke the mathematical chain. If this condition is true, then invoke the coding chain. Now this is our router chain is getting created. So the main routing logic, main routing happens here. So here first this is the initial mapping that I am creating, that you have seen in the previous examples as well. I think with the sequential chain. In this mapping I'm just creating two maps. So one is route and one is input. So input is whatever input I will be providing in my when I will be invoking the chain, that will be the input. As you know, whatever input I provide while invoking the chain, that comes here, and that input I am storing as a input key value pair. Then I am invoking a classifier chain, which is this classifier chain. So this input will go to this classifier chain. It will get replaced here. As you know, this is only one variable, and we are passing the variable value in the while invoking the chain. So this will get, this whole mapping will get passed here in the classifier chain as well, and this input value will be replaced by the value which we are providing while invoking the chain. So this is all same, very similar and same as we have seen in the sequential chain and everything, like how the input get passed and how the chains will get triggered. The only difference here is this runnable branch. So as you have seen, I have seen runnable parallel and runnable lambda in the previous examples. Yeah, this is a new example, runnable branch. So what runnable branch will do, here you can provide your here you can provide your conditions. So I have written two different conditions, right? Like this math, to invoke the math chain and coding chain. If you, yeah, here math chain and coding chain. So these conditions you can provide in the runnable branch. So what you are basically saying, after this happens, whatever the output of this block is, when this output will be passed as an input to this runnable branch, so it will say if is math is true, then math chain will get invoked. If is code is true, then code chain will get invoked. In general, in like default, the final else case, general chain will get invoked. So what will happen? This block will give you an output mapping of with two key value pairs, right? One is the route, which will have the value of this particular thing, right? Which is either math, code, or general. Then input. Input is this input, this question. So why do we need this route as well as input? Route we need to for a routing logic. So this whole mapping will get passed into this x. Now this x will say if x route, which is this, is math, then invoke the math chain, or if x route is code, then invoke the code chain, else general chain. Then this input we need in the initial chains, right? Like this math chain, code chain, and general chain, right? So that is why we need both to for our branching logic. So now how this will work? Let's run these examples one by one. I'll just comment out two, and I'll just run this one first. Let's wait for a few seconds. So yeah, so as you can see, I am asking a mathematical question. What is 144 multiplied by 12, right? So this is a mathematical question, and as you can see, my prompt says solve the following math problem step by step, right? So it's actually giving you steps how it solved that problem, right? So it's breaking down the multiplication and whatever it is doing. I'm not going into that. So it's explaining you how actually he's doing the multiplication, like 144 times 12 and things like that, and so on, so on. Then there is the final answer that this multiplied by 12 is 1728. So as you can see, there is no output of this that is related to these types of prompts, right? Like answer the following questions clearly or explain the following programming concept. There is no concept, right? So only the mathematical chain got triggered. Similarly, if I try to invoke this chain with this type of prompt, explain this particular concept, then you will see general chain will get triggered. General chain or the coding chain? Yeah, programming concept. This will get triggered. Code chain will get triggered because this is a programming concept, HTTP multiplexing. So now you are getting a different kind of answer, like you are getting the explanation out of it. Then similarly, if I invoke the last one, yeah, so now you can see it's a single line answer, because now you are asking the LLM to answer the following question clearly, like as a simple statement, right? So if you want to really see that only the match chain or things like that got triggered, then you can I'll just print something here. So let's say if I print the value of x here, let's see what is the output of the classifier chain for all these three as well. That will probably help you understand things. So let me run it using this only. So as we have two, right? So both of them got invoked because it will try to check for what chains to invoke based on the input for each of them. So is math will be false because now the route is general, right? So this will return false, this will return false, hence this only this thing will get triggered. And let's see it for this particular input, and I'll run it again. So now as you can see, again it's getting general. So there is some problem in my classifier prompt. So it's not triggering this as a coding prompt. It's not categorizing it into the code actually. So that is why the general is getting triggered. So let's check the first one. The math should be the output of the classifier prompt. In this case, we have to refine our classifier prompt. Like you have to say explicitly if the program is, if user is asking about a topic that is related to any programming concept or something like that, then return this as the output, right? Basically by code, I think it's taking code, the actual code, understanding the actual code as an input, which is not the case, right? So in this case now, as you can see, the category is coming as math, right? So as you can see now, as the category was math, so you're not seeing two outputs here, right? For this thing, earlier you were seeing for general one, you were seeing two outputs, right? Because first it was going into this, then it was going into this, then coming to general chain. But in case of math, this got triggered, right? So it went to this math function which says true, then it triggers the math chain, and so that's all, right? uh, let's see if it is trying to, yeah. So this is the final answer. These are all the steps written by the LLM and nothing else. So there is no output like this anywhere else, right? So it's going to the math route. It's getting this getting true from here, and it's triggering the math chain, and hence it's not going to look into these two. So that is what happens with the routing LCEL chain. It takes a condition, it takes a chain, and if the condition is true, it triggers that chain, and that is all it does, like a simple if else if statement, only in terms of chain. So I hope this is clear to you guys. If not, like, just uh, go back to the video, start of the video and watch it again, and maybe try it on your own, because that is the best way to learn these things, like trying it on your own and changing things here and there and trying to experiment on it. So that is the best way to learn it. Let's move to our next topic, which is multi-prompt chaining. So multi-prompt chaining uh, is a um, is a behavior that you can achieve, like when you have a problem statement, and to answer that problem statement, your style, tone, or each time something differs in your prompt, like the whole logic will remain same, only you want to change your prompt each time based on the problem statement. So one such example could be like you have a review. So let's say you have a movie, you have gotten a review on that, and based on the review, you need to return the answer to the user. So everything else remains same, whatever else logic or everything else you have, only based on the review, how your LLM should answer, that will be only different thing, right? So the prompt will be different. So let's first look into the theory. Use it when the task is same but the prompt must change, like casual or formal answer. For example, for a same question you want a casual or formal answer, or beginner or expert explanation, finance or healthcare wording, things like that, right? When the question remains same, when the logic remains same, but the tone, style, or you have to use a different prompt to answer that particular thing or handle that particular task. So a simple example is movie review, as I said. So here I have created three chains: positive, negative, and neutral. So my positive chain is saying, you are a customer success agent. Write a warm and appreciative response to this positive review. So basically, this prompt is to handle a positive review. And obviously, I'm creating a simple chain directly here, like I'm creating a prompt and then LLM and parser, as we have seen like a lot of times till now. Then there is a negative chain, which is saying you're a support manager. Write a polite apology and ask for more details to resolve the issue. So this is about a negative chain. So here you are asking to give feedback on a negative chain, a negative review. Then if the review is neutral, like not so positive, not so negative, then acknowledge the feedback and thank the user for sharing. So these are three prompts that we have written, and they obviously take a review. So as you can see, each of them has an input review in them. Now you have your classifier, again something similar to this routing logic as we have written here, and here we are just checking what type of review it is using LLM. So here classify the sentiment of the following review in one of them: positive, negative, neutral, and you are passing review as an input to it as well. And again you are creating a simple chain out of it, which is sentiment, prompt, LLM, and parser. Now you can write your own logic here. So basically this is a normal function in Python. Here you are accepting a data. In that data you are expecting a sentiment and a review, and this is just the simple if else logic that I have been writing. So if the sentiment is positive, then do this, invoke this chain. If negative, invoke this change. Else neutral, invoke this neutral change. Kind of a runnable branch thing, just in the multi-prompt thing. So similar thing, right? If you have you were here doing things like by runnable branch, but here you are just writing your own logic. So here you can write more complicated logic, right? If you have more complicated logic, you can do things here. So router chain is simple. You are just making a mapping, initial mapping, like sentiment review. So you are invoking the sentiment chain. Sentiment chain will give you what type of review it is: positive, negative, or neutral. And you are keeping the review in the provided with the input into this mapping as well. So runnable lambda, what it will if you are already aware of runnable lambda by now, right? Runnable lambda just takes a lambda function and make it a runnable, right? So here what will happen, at first the input will pass to this mapping. So here it will invoke the sentiment chain, it will give you the whatever type of review it is, then it will persist the review whatever you are passing in the input, and then it will just pass it to the route by sentiment function. So this data will contain a mapping with a sentiment and a review in it, and this is now again the simple logic like a normal Python function, right? Nothing uh, difficult. So now let's see the output of this. So I'm invoking this chain 3 times with a review, a positive review, then this is a negative review, nothing special, this is a kind of neutral review, right? So it's giving the feedback on every review, right? So thank you so much for your kind word. This is for the positive review, we're thrilled to find out that you found this fast and you know everything. Then for your negative review, thank you for reaching out and sharing your experience with us. And this is the apology, like for a negative review, like if I look into the output, then third will be the neutral, this is the apology. Then yeah, this is the third review. So this is like a feedback and everything, like it's kind of neutral, not appreciation, not a negative review. So kind of a neutral response. So based on what sentiment is being written by this LLM, you are triggering separate chain based on the inputs. So similar kind of a runnable branch, but on your own. So this is another example, the same similar example, just on a different domain. Um, exactly same thing actually. So here is a technical prompt. You are a senior software engineer, answer the question in deep technical clarity, then explain the following concept in simple terms. This is like a simple prompt. And then marketing prompt, like with the product marketer, answer the questions in a personality benefit focused way. Just the domain is different. Similar chains I will be creating out of them: technical chain, simple chain, marketing chain, and the style classifier, everything, from template, this everything. So now I'm creating a style classifier everywhere. So style classifier here, similar thing like this previous example. It was just based on the negative review, it's based on uh, the question written by provided in the input. So basically it will be giving us 3 different categories: technical, simple, and marketing, which we will be used to invoke these 3 types of chain, which is technical chain, simple chain, or marketing chain. So same classifier and same function, where here we are just taking x. So if the style is technical, then invoke technical chain; if marketing chain; else simple chain. And then we are creating a multi-prompt ICL chain using runnable lambda, same thing as we have done above. Mapping with the style and the input. Style will be decided by the LLM using this classifier, and then the input. And then we are calling a route to prompt function using reliable lambda, and this function will handle which change to trigger on which input. So very similar example like above, just to make things more clear, I've just written this. Let's see the output of this. So yeah, this is the output. The first prompt is explain HTTP2. So first is explaining HTTP2, then where should I use your cloud platform. This let's okay, still running. I think I just only got the answer for the first prompt. Let's wait for it to run fully actually. Let's wait for a few more seconds. No, I think we got few answers. So what is this is about caching, and this is about where should I use your cloud platform. So if you will see in the bottom, you have answers about caching, right? Caching is this and all those things. And where should I use for platform? This is about caching. I think this is the output of the third prompt. And yeah, this is the, I think this is the output of the second one. So about the cloud platform, not only streamlines operation, etc, etc. So this is all these 3 are getting printed. So if you want to see the output of the one single prompt, I can do that. So this is getting mixed with each other, right? So let's trigger only one of them. Let me comment out this part. Let me comment out this part and trigger it again. It will take again few seconds to get the answer. Yeah, so that was the answer to our second question about the cloud platform and everything. So this is how you can use multi-prompt chain. Now why I took these examples, because of this multi-prompt chain class present in the LangChain 0.1. So in 0.1, when you were using these classes to create chains, there was a class present called multi-prompt chain to specifically do this task, this type of task. So I will be showing this example in case you have worked on it. So now with 0.3 and with the LCEL language and the new versions of the LangChain, this thing is discouraged. It is supported, but it is discouraged. So to convert this type of behavior, you have to write code in such manner, like the way I am showing here. So I'll just show you the old code, like how it used to be. So same thing, we have a technical prompt here, and we have a simple prompt here, and we have a marketing prompt here. Now, as you know, in the old behavior, we used to create LLM chains using this LLM chain class. So here we are providing our LLM and a prompt, and LLM prompt, LLM and prompt for all those three chains: technical chain, simple chain, marketing chain. Now again we have a classifier which again classifies into the similar categories: technical, simple and marketing, and we are again creating a prompt template out of this router template outfit. We are using prompt template class of LangChain used to create the template. Then we have LLM-RouterChain to where we are providing LLM and the router prompt that we have. Okay, now we have multi-prompt chain. So the way you were doing things here, it does things in a similar manner, just the way of writing things is different. So in this multi-prompt chain, you provide your router chain. Router chain is the chain which helps in providing the direction, like which route the prompt should go, which chain should be triggered. Then the destination chains, which are like this technical, simple and marketing chains, the destination chains that you have created above here, these three. Then the default chain, like the else condition, if nothing matches, then by default which one should get triggered. Verbose is true, like if you want the LN to be more verbose. Okay. All right. So this is how you used to create a multi-prompt chain way back. Now the new way of writing chains is like this only. So it's just a similar thing, as it takes everything, right? Router chain, it decides which route to go through, like it will just give the answer which category the input belongs to, and then it will go to destination chains based on that input, like technical chain, of simple chain, of marketing chain, and default chain is simple chain. Like similar, just the way of writing things are different, and same question. So if I run it, I think I'm getting some error in the LM router chain from LLM. Let me look into that. Okay, I finally fixed this. So let me explain the fix. So this LLM prompting, this multi-prompt chain, it needs a router output parser. So router output parser, I have just modified my code for that. Let me remove this commented part. So here in this from LLM, in this router prompt, we are now passing router output parser. Router output parser needs a specific output. So here we have changed the prompt to return the output in this following JSON only: destination and next inputs and the user question. So now I'm just using a router output parser, and everything else is same. We are still creating the multi-prompt chain the same way, and we are creating simple chains and destination chains, and we are passing all of them in the multi-prompt chain. Now if you will see, when I am executing these three inputs, you can see the output is coming clearly. Like this is for multi-prompt chain, the output is coming from for HTTP multiplexing, and this is for which should use a cloud endpoint. So this is the answer for that. Then about caching, this is the answer about the caching. So this is how you used to use multi-prompt chains back in 0.1, and the new way of creating these kinds of chains is like this. Like this is way simpler, right? So here you are using parsers, output parsers and everything, and you are creating objects out of everything. So the code now you can use to create this type of chain is like this. So this is way simpler, as you are using LCEL and everything. So you have to write less code and it will give you the exact same output. So you can use the new way. Okay, so this is all about this particular video. I will be explaining these two chains only in this video, and in the next video we will cover custom chaining. So how to create our own custom chains using two different ways. So I will be covering that in the next video, and that will be our last video on the chains, and then we will start with other topics on the LangChain. So I hope you enjoyed it. Let's see you in the next session, and Please practice on this. So practice will make you more clear about all these things. And have a nice day, and please like, share and subscribe.